With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that in the given figure, the faces ABCD made of glass with a refractive index n form a dihedral angles. Angle A is given as to be 90, angle B is 75, angle C is 135, angle D is 60 degrees. So this is the figure which has been for which we have been talking. Now what we need to find, there is a beam of light which falls on the face AB and there is a total internal reflection on the face BC. That means at this face there is total internal reflection and the light is escaping from the face AD. Now we need to find what is the range of this n, that means refractive index, and also we need to find the range of the angle of incidence for the beam onto the face AB if the beam that has passed through the prism in this manner is perpendicular to the incident beam. Okay, so this is another condition which has been given. Now we just draw our figure. So first of all we just say that, let's say this is our incident beam. Okay, let's say this is our incident light ray. So from here, from the normal, what would be this angle? This would be the angle of incidence. We call this as to be our alpha because here it is given as to be alpha. Now after that what will happen? So there would be refraction at this surface. Light would bend towards the normal because it is coming from the ear. Refractive index is 1. It would be nearer to a denser medium. Now when it comes here, it is given in the question itself that there is a total internal reflection. That means whatever is the angle the light ray is making with the normal, it would be the same as the angle of reflection at this surface. It is given in the question itself. Now what will happen here? So from here the light ray would be escaping. Now how does it escape? It escapes such that it is making an angle of 90 degree with the incident light ray. That means it is basically we just draw the, first of all we just draw the path. It would be something like this. Now if we just proceed this angle in the backward direction, okay, like this, if we just proceed the angle in the backward direction, this angle would be 90 degree. It is also given in the question itself. Okay, now we just mark our point. Let's say this is ABCD which has been given. Let's say this is our P, this is our Q. Okay, now let us suppose that this is the angle of incidence. Let's say this is the angle of refraction at this surface. Now what is this angle given as to be? Angle B, we just check our angle B, it is 75 degrees. So this is our 75 degree. Now from this part, we can say that if we just join A and C, we can treat this as to be our prism. Okay, and this would be 75 would be the angle of the prism. We call this as to be our R. Sorry for writing alpha. This is our R. Now what would be the angle of incidence at this surface? Okay, at this surface we call this as to be our R dash. Now what would be the value of R dash? Now if we just consider this to be one of the prism, okay, A, B, C is one of the prism. We know that R, this R plus this R dash, this is equals to angle of the prism, which is given as to be 75 degree. So we can say that our R dash would be equals to 75 minus R. That means this is our 75 minus R. So what would be this angle? This would again be our R dash, or we can say that 75 minus of R. Okay, now here the light ray is coming. Now what would be this angle, and correspondingly what would be this angle? Now we know that this angle is alpha. So what would be this angle? This angle would be 90 minus alpha. We just write here 90 minus alpha. Now this is perpendicular. It is given in the question itself. So what would be this angle if we just make our triangle? So this angle would again be alpha. Now if this angle is alpha, what would be this angle? We say that these are the vertically opposite angle. So this would be alpha. This is 90 degree. So what would be this angle? This angle would be 90 minus alpha. Now again, this is 90 minus alpha. No, okay, this is 90 minus alpha. So correspondingly this surface is making what angle? This angle would be what? Because these are the vertically opposite angle. This angle would be 90 minus alpha. We just write here. Now the total angle is 90 degrees. So what would be this angle? This angle would be alpha. That means light is emerging at an angle on which it was coming. That means what should be this angle? This angle should be R. Why? Because when the light is coming at an angle of alpha, it is bending with an angle of R. Now if this is the reverse situation, now if the light is coming at an angle R, it should go out with an angle of alpha. Okay, this should be considered. Now this angle is what? This is 60 degree. This is what? This is 135 degree. Okay, now what is this angle? We know that this angle is 75 minus R. This is our R dash, 75 minus R. So what would be this angle? We call this angle to be angle P. So angle P would be, total angle would be 90 degree because this is normal. So it would be 90 minus 75 minus R. So this would turn out to be 15 plus R. Now if we just check our quadrilateral, so this is forming a quadrilateral, this PQDC. Now in the quadrilateral PQDC, we say that angle P plus angle Q plus angle D plus angle C, this would be equals to 360 degree. Now we put the values. Angle P we have already stated here, 15 plus R. This is our angle P. What would be our angle Q? This is R and this is 90 degree. So it would be R plus 90. What is angle D? It is given as to be 60. What is angle C? It is given as to be 135. This would be equals to 360. Now if we solve this, then our angle R would turn out to be, R value, this would turn out to be 30 degree. Okay, this would turn out to be 30 degrees. This is the value of r. Okay, now if this is the value of r, what we need to find? We need to find what would be the range of the value of n. Now if we consider here, this is our r dash. So if the total reflection has to take place at this surface, then our angle r dash should be greater than the critical angle. So we say that for TIR, angle r dash should be greater than our angle, greater than equal to angle C. We just take the equality also. So what is our r dash? It is 75 minus r. So if we put the value 75 minus r, and r value is 30 degree. So this should be greater than our critical angle, greater than equal to critical angle. Now we know that critical angle is written as sine inverse of 1 divided by refractive index. So what would be this value? This value would be 45, greater than equals to sine inverse of 1 divided by n. So if we take the sign to the other side, so if we just take the sign of this equation, it would be sine 45. Sine 45 means 1 divided by root 2 should be greater than equals to 1 divided by n, or we can say that our n should be greater than or equal to this root 2. So this is one of the limit. Now another limit we will be getting from the Snell's law. If we just apply the Snell's law at this surface, we say that here the refractive index would be equals to 1. Here what is the refractive index? It is equals to n. So 1 sine alpha, this would be equals to n into sine of r. So this is by the Snell's law. So we say that 1 into sine of alpha, this would be equals to n into sine of r. Now what is our r? R we have calculated to be 30 degree. So we can say that n would be equals to sine alpha divided by this sine 30. Sine 30 is 1 divided by 2. So we can say that it would be equals to 2 sine of alpha. So we know that what would be the maximum value of our sine alpha? Sine alpha maximum value would be equals to 1. So we say that n max. So n maximum value would be equals to what? It would be equals to 2. So we can say that our n should lie between. So it should be greater than greater than root 2. And what is the maximum value? It comes out to be 2. So it should be less than or equals to 2. So this is the limit for our refractive index. Okay. Now we know that this is our refractive index. Now we can also say that our refractive index would be equals to refractive index. If we just put into the condition, we say that refractive index is sine of angle of incidence divided by sine of angle of this refraction. So this is greater than equals to root 2, less than equals to 2. So we can say that root 2, if we just cross multiply, so it would be sine, and what is the value of r? It is 30 degree, less than or equals to sine alpha. So again if we cross multiply this sine r, it would be equals to sine of 30 degree. Now what is sine of 30 degree? It is equals to 1 divided by 2. So if we put the value of sine 30, it would turn out to be 1 divided by root 2 here, less than equals to sine of alpha, less than equals to, it would be 1 divided by 2. So what would be the range? If we take the inverse, sine inverse of 1 by 2, it would be 45 degrees, less than equals to, so this is also 2 here. So if we multiply 2 here, so it would turn out to be 1. It would turn out to be 1. Sine 30 is 1 divided by 2. So that means alpha less than equals to, what is sine inverse of 1? It is equals to 90 degree. So we have calculated the range for our alpha. So this is the range for our alpha. Okay. And we have calculated the range for our n. So this is what we need to find. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.